Hello everyone, welcome to the BOOKphilic YouTube channel. Now in this video we are going to discuss about the translation of an assignment statement. What does it mean? It means that a statement or a line of code will be assigned to the translator, and what is the translator here is nothing but a compiler. So how the compiler will translate this assignment statement into the machine code will be discussed in this video. So be along with the video and don't skip it in order to understand the different phases of compiler in one example. Okay, so let us start with the beginning. Okay, now at first we are assigning position equal to initial plus rate star 60. Okay, now position equal to initial plus rate star 60. What does it mean? It means that 60 is an integer, rate is nothing but the identifier, or you can say variable. Initial is nothing but the variable, and position is nothing but another variable. After initial and rate and 60, after that arithmetic operation, it will get stored in the position variable. So this is our first assigned statement that we are going to convert it into the machine code. So let us start it. Okay, so number one, lexical analyzer. As we have discussed that lexical analyzer is the first phase of compiler, so that's why it will be taken as an input into the lexical analyzer. And what is the output of the lexical analyzer? It will just generate the tokens. So it is nothing but a token. So let us discuss about the token. So first of all, id1 means position is the id1, and equal to operator is the another token. id2 is nothing but initial, and plus operator is nothing but the another token, and id3 is nothing but the rate, and the star is the another token, and 60 is nothing but the integer or constant, it is another token. So there are total 1 2 3 4 5 6 7. So there are total number of 7 tokens present in the lexical analyzer phase. So these 7 tokens will be taken as an input to the syntax analyzer, and it will generate the parse tree. Now this is a parse tree, that is, it will just start from the operator equal to. So this is nothing but the starting symbol equal to, and here it is the operator plus, here it is the operator star. Now you will be telling that star has the higher precedence. Star is nothing but multiplication, and according to Bodmas rule, star, that is the multiplication, is also having the higher precedence than the plus. So why it is at the lower of the tree? Why it is at the lower of the past tree? Yes, it is truth that whatever is at the lower of the past tree will be getting the higher precedence than the another's. That is, here it is also multiplication has the higher precedence than operator plus. So first of all, this 60 will be get multiplied with the id3, and id3 is nothing but the rate. So this id3, after multiplication operation, this whole will get added with id2 and will stored into the id1. So in this way, the parse tree generated from the syntax analyzer, and this parse tree will be gotten into the consideration as an input to the semantic analyzer phase, which will just verify whether the parse tree generated from the syntax analyzer phase is valid or not. It will validate the parse tree, it will verify the parse tree. So now let us move on to the verification. Position, it is a variable identifier, that's why it is known as id1. Id is nothing but the short form of identifier. This is another identifier id2, this is another identifier id3, and this is a constant. So all are according to the syntax of the rules, so where is the problem? The problem is that it will not take the 60 as an input input, it will just convert the integer type to float type. That's why it is written here int to float. Int to float. I hope it is visible. Okay. Int to float. Here it is. Int to float. Int to float. I hope it is visible. Int to float. Okay. Now int to float, it is 60. Now it will be after all considered as 60.0. Now this is the verified pass tree that is generated from the semantic analyzer phase. Now let us move on to the next phase, that is intermediate code generator. This verified pass tree will be taken as an input to the intermediate code generator and will generate the three address code. What do you mean by three address code? It is nothing but the minimization, you can say in that way. The three address code is nothing but the code which takes only three variables: number one variable, number two variable, number three variable. Only three types of variable will be taken as an input in the three address code. Now here is only t1, t2, t3. That's why it is known as three address code. Here not more than three variables are taken as an input. That's why it is known as three address code. Now how this three address code is generated? Number one, you will have to consider this. So here it is, what int to float will be stored in the t1 phase. Okay, t1 is nothing but an identifier, you can say the variable. It is the first address code. It will be stored in the t1 address, and after storing the into to float value to the t1, it will get multiplied with id3. Here it is. Hope it is visible to you, and it will be stored in the second address. And now whatever will be the stored in the second address will be added with id2, that is the second identifier, and it will again store to the t3 that is present here, t3, and this t3 will be assigned to id1. This t3 will be assigned to id1. In the same way, you can say it is nothing but a t1. T1 will be get multiplied with id3, and this will become t2. This t2 will get added with id2, and whatever will be generated will be assigned to id3, that is id1. So in this way, this whole process will go on, and three address code will get into the generation. Now after generation of the three address code, the code optimizer will take as an input the three address code and will generate the optimized code. Now optimized code, I have already told you that it is nothing but the minimization of the lines of code. Okay, so here we have written the 4 line of code, but here we have minimized it into the 2 lines of code. What is it? T1 is added with the id2 and will stored into the id1. That id1 and 60 will be 60 will be, wait 1 second. So here it is, 60 is multiplied with id3. Here it is, 60 is multiplied with id3, and after multiplication it is added with id2 and get stored in id1. That's what here it is written, that t1 is nothing but id3 multiplication with 16, and this will be stored after added with id2 into id1. So hoga ye optimized? Yes, it is optimized now. Now code generator will generate the target code. Code generator will generate the target code. It is the target code that we have gotten after the compilation process. Now what is ldf? Ldf is nothing but load float type, and id3 is nothing but id3 is nothing but, let us make you understand that what we have written, that initial plus rate star 60, and here the id3 is rate. So id3 will be stored in r2. That's what it is written here, that you will be loading the id3 into r2 register, and after loading it will get multiplied with 60.0. means 60.0. What does it mean? It means that it is a floating type now. It will get multiplied with R2 and will again stored into the R2 register. That's what it is written here, mul. Mul is nothing but the short form of multiplication, and f is nothing but the short form of float type. So that's what. So you know that in arithmetic, something multiplied with the floating type constant, it will generate the floating type value again. The result will be a floating type. That's why it is written here mul if r2 hash 60.0. Hash is nothing but used to represent the floating type variable. So it will be used into that r2. It will get multiplied with r2 and will stored again into r2. Okay, now ldf is nothing but the again load. So we have to load it again. What we have to load it again? Identifier 2. This will be loaded in R1, and this R1 will get added with R2. As we have written here, the ADDF means add the floating type R1 and R2 and will get stored in this R1 again. And STF nothing but store floating type, and this ultimately store the R1 into the ID1. Hope you have understood. If you have not understood, you can pause it or you can revise it again and again. It is very well understandable. Okay, and that's it for the translation of a program. Thank you guys.